morning students. Today we will be working out a problem which includes both the latent heat calculation and also sensible heat calculation. Calculate the enthalpy of zinc vapor at 1200 degrees centigrade and atmospheric pressure relative to the solid at 10 degrees centigrade. That's all is the question, but some amount of data is required to solve this. So what is the question here? Calculate the enthalpy of zinc vapor at 1200 degrees centigrade. That means we have a zinc vapor, suppose at 1200 degrees centigrade. Because the temperature is high temperature, it contains some heat content. Okay. So how does this heat content is obtained by this zinc vapor, and which is relative to solid at 10 degrees centigrade. That means initially we have solid zinc at 10 degrees centigrade. We are supplying heat to this. Okay. Initially we have solid zinc at 10 degrees. That is relative to the solid at 10 degrees centigrade. Then supply heat. Then what happens? This solid turns to liquid, and then liquid continue supply heat. Then liquid turns to vapor, and then this vapor you will have now here the final condition. This is the final condition is vapor at 1200 degrees centigrade. So till now what all the heat that we have supplied, that will be gained by this vapor, and it will be this vapor will be possessing that heat content. That only is called the enthalpy of zinc vapor, because in industries it is required. We may have solid form, but we want to convert into vapor form. Then what we do? What the chemical engineer do? Supplies heat. Then the zinc will melt to liquid, and then that liquid will be converted to vapor. Then that vapor will be heated to 1200. Like that, by supplying heat, we will convert solid zinc to vapor, zinc vapor. Okay. So what quantity of heat is to be supplied? What quantity of heat is to be supplied to convert solid zinc at 10 degrees centigrade to vapor, zinc vapor at 1200 degrees centigrade? That is our question. Okay. What quantity of heat is to be supplied to convert solid zinc at 10 degrees centigrade to zinc vapor at 1200 degrees centigrade? So you cannot calculate in a single step this whole thing, because there are several stages in this. So that is the question, and then data is given. To solve this type of problems, we need some data. What is that data is here? That is like information like melting point and then boiling point and mean specific heat data are required to solve this type of problem, because at melting point and boiling point, see, at melting point and boiling point, phase change takes place. Phase change takes place. This is the concept which we have already discussed in previous classes. At melting point and also at a boiling point, phase change takes place. T is constant. Okay. And then the remaining range, that is to heat solid or to heat liquid or to heat vapor, then that is sensible heat. Okay. Sensible heat calculation. For this, CPM is required, mean heat capacity, and also this is 3 here. This may be different for the solid, liquid and vapor. Different values. We will have different values. Okay. So this is the main concept. So we will divide into stages. Each stage we will calculate Q, then add up to get the final value of Q. In order to solve this problem, then this is just drawing a diagram is very advantage. One is first start with the solid zinc here. That is means like this, like a graph form. If you draw here, this is temperature. Okay, this is temperature. This is supply of heat energy. As supply of heat energy is increasing, what is happening to the temperature? Okay, so zinc vapor, initially we have somewhere here, that is solid zinc. We have solid zinc. We have initially solid zinc. Okay, then this solid zinc, when you supply heat, the temperature will rise. The temperature will rise till melting point. So what is the melting point of zinc? Melting point of zinc is 419 degrees centigrade. Okay, so till 419 degrees centigrade, zinc can exist in a solid form. So it will raise its temperature here. So this is also solid zinc. Okay, so what is this temperature? Say 10 degrees centigrade. What is this temperature? Up to 419. So here 419 degrees centigrade. Okay, then afterwards what happens? Still we are supplying heat, but the temperature will not rise because it has reached its melting point, but solid will melt to liquid. So temperature will not rise. Here what now? Liquid zinc. Liquid zinc. Okay. This also happens at 419 only. Then what happens then? Still supply heat. Then from 419 till what temperature it will rise? Here, this is liquid zinc only. This is liquid zinc only. This is what temperature here? Boiling point. Till boiling point of zinc, 907. 907 degrees centigrade. That is at 907 degrees centigrade. That is this value. 907 degrees centigrade. It can exist in the liquid form. That is the boiling point here. Then what happens? Still supply heat. Temperature will not rise. But liquid form, zinc will convert from liquid form to vapor form. So this is zinc vapor. Zinc vapor. This is also at 907 only. Temperature is not changing. 907, 907. Here also solid zinc to liquid zinc. This is at 419. This is at 419. This is also at 419 degrees centigrade. From here to here, temperature not changing, but phase change is taking place from solid phase to liquid phase. Here also temperature is not changing, but phase change is taking place from a liquid phase to vapor phase. Then this vapor, but what is our question? It is enthalpy of zinc vapor at 1200 degrees centigrade, not at 907. At 907 we are getting zinc vapor, but the question is at 1200. What does it mean? The vapor is heated from 907 to 1200 degrees centigrade. So again the temperature will rise. Okay. Again the temperature will rise. So this is zinc vapor at 907 degrees 1200 degrees centigrade. Zinc vapor at 1200 degrees centigrade. So this is the diagram to explain this problem, whole problem we are showing in the form of a diagram here. So what is this? Once again we will see zinc vapor. Initially you have in the solid form. Solid zinc is heated to then solid zinc at 419. Initially 10 to 419. Now here this is what? Phase change. Phase change is taking place. So let this be Q1. Okay. And here let this be Q2. And this is Q3. And this is Q4. Like stages we have divided. Q. Okay. Now we wrote all this. So what is Q1? What is Q1? Q1 is quantity of heat required. Q1 is quantity of heat required to raise the temperature. To raise the temperature of solid zinc from 10 degrees centigrade to 419 degrees centigrade. Okay, from 10 degrees centigrade to 419 degrees centigrade. Then what is Q2? What is Q2? Q2 is also quantity of heat required. Quantity of heat required to melt. After reaching 419, it is melting to 419. Required to melt zinc. That is from solid to liquid. Okay. Then what is Q3? Melting is taking place at 419 only. Okay. Then what is Q3? Q3 is heat required to heat liquid zinc. To heat liquid zinc from 419 to 907. To 907 degrees centigrade. Stages we are dividing into stages. So here then Q4 is equal to quantity of heat required to convert liquid zinc at 907 degrees centigrade to zinc vapor at 907 degrees centigrade. Okay. Then Q5 is equal to heat required to heat zinc vapor from 907 degrees centigrade, okay, to 1200 degrees centigrade. Like that we are dividing into stages here. So here this, what is Q1 here? This is what, because temperature is rising here, sensible heat calculation. Okay, this Q1 is sensible heat. sensible heat. You can calculate using N CPM dt. Okay, and this is what? Latent heat. Latent heat. And you can calculate using N lambda F. Because it is fusion from solid to liquid, we are taking lambda F. And N or M, that depends upon the units of this. If it is per unit mass, you take M. Per unit mole, you take N. Here also same reason. Okay. Then what is Q3 again? Q3 is also again sensible heat. Sensible heat. Okay. This is also N CPM dt. Using this we calculate. And what is Q4? Again, latent heat. Okay. This is again N lambda. Here it is F for fusion. Here liquid is converting to vapor. So latent heat of vaporization. Okay. Next. This is again what? Here also vapor form. Here also vapor form. Phase is not changing, but temperature is changing from 907 to 1200. So this is what? Sensible heat again. This is again sensible heat. That is N CPM dt. Okay now? So using this diagram, you can easily understand this problem. Now each stage, first calculate Q1, then Q2, then Q3, like that. All 5 Qs you calculate. Then the total energy that is supplied, total heat energy supplied, total heat supplied, total heat supplied is equal to Q, is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. Okay. That is how to calculate. So we shall calculate each one now, each Q. Now before calculating the value of Q, first it is better to take one basis, because if you observe these values, the question is arising now. You can check the question. See, some data, suppose mean heat capacity of zinc vapor is per kilomole, and this is fusion is per kilomole, and heat of vaporization is per kilomole, but specific heat of liquid zinc, solid zinc are given per kg here. Okay, per kg it is given. So some data points are per kilomole and some data points are per kg. So what we will do is better, I will tell you the easy way how to start the problem. Because more number of data points are given per kilomole. Let us take like this. Base is 1 kilomole of zinc. Okay, base is 1 kilomole of zinc, and 1 kilomole of zinc or molecular weight, if you take here, that is nothing but 65.3. This is also equal to 65.3 kg. So what is your basis now? If you want to pick out in number of moles, it is 1 kilomole. If you want to pick out the kg in kg, that value is 65.3. So while working out, you will understand why we are writing both. So what is Q? I already wrote in words, no? So now I am not writing again. What is Q1 is the quantity of heat to be supplied to convert solid zinc at 10 to solid zinc at 419. So it is a sensible heat calculation. So N CPM dt here. This is the equation we need to take. And what is CPM? Here NRM depends on CPM. CPM of, that is mean heat capacity of solid zinc you need to take. In the problem, if you check the question, all three are given. If zinc is in the solid form, what value? Liquid form, what value? Vapor form, what value? So what is the value in the, refer to the question? Solid form, mean specific heat of solid zinc, 0.105 kilocalorie per kg it is given. So you take now M, okay, because it is given per kg. So when you calculate here, M is what here? Here M is what? 65.3 into 0.105. 0.105 into dt. What is dt? It is heated from 10 degrees to 419. So 419 minus 10. This is, now write the units below that. Don't forget to write the units. With that you will do very correctly. So this is kg and this is kilocalorie per kg per Kelvin, and this is Kelvin. This is Kelvin only. 273 plus 273 gets cancelled. Okay. So kg, kg, Kelvin, Kelvin. You will get some kilocalories. Okay. Now please understand this once again. Solid zinc part we are taking Q1. Heat to be required, to be supplied to heat solid zinc from 10 to 419. Okay, that is sensible heat calculation. So MCPM, here we wrote N, but general I wrote here. Since you have per kg value, we are taking here M. Okay, so in this is actually M now. So because of the unit of CPM, that's all. So here, and higher minus lower temperature. So you will get the value of Q1 as 2804 0.3085 0.3085 kilocalories. Okay, so we calculated Q1. In the same way, now also calculate Q2, Q3 and so on. So now Q2 we will calculate. What is Q2? Heat to be supplied. Heat to be supplied to melt. To melt solid zinc at 419 degrees centigrade. Okay, at 419 solid zinc is converting to liquid zinc. 419, this is latent heat calculation. So this is given by NRM, we will say lambda F. What is the latent heat of fusion value is given? Latent heat of fusion. Latent heat of fusion is 1660 kilocalories per kg mole. This is given in 1660 kilocalorie per kg mole. Okay. So because it is per kilomole, here shall we take N. So what is in 1? If you want to write N, take 1. If you want to write M, this is 65.3. So 1 into, this is kg. Okay. So kg mole, this is kg mole. Okay. This is 1 kgmole, kgmole. So this is equal to what now? 1660 kilocalories. That is the Q2. Okay. Next, Q3. Q3 is equal to heat to be supplied. Heat to be supplied. Now what we have Q2 calculated? We have liquid zinc, okay, at 419. This liquid zinc is to be heated to solid zinc. That is up to boiling point it can exist liquid form. From melting point to boiling point. That whole thing we need to take care. Heat to be supplied to convert liquid zinc to zinc vapor. Is this Q3 here? Liquid zinc to liquid zinc to liquid zinc at, you write, liquid zinc at 419 degrees centigrade, 419 degrees centigrade to liquid zinc at 907 degrees centigrade. Okay, Q3 is this part. We have zinc liquid at 490. We need to heat it to liquid zinc at 907. Up to its boiling point, it can exist in the liquid form. This is boiling point, isn't it? This is a boiling point and this is a melting point. And this is what? Melting point. Okay. So this Q3 from here to here. This is N CPM dt. N or M we will see, depends upon the unit of this is what now? Mean heat capacity. Mean heat capacity of, for liquid we are calculating, so of liquid zinc. Mean heat capacity of liquid zinc. It is given in which unit we will see. Mean heat capacity of liquid zinc. Liquid zinc 0.109 kilocalorie per kg it is given. Okay, that means here specific heat is given. Okay, given. So what we take now? M we take. Okay, because it is per kg. This is, you need to take a liquid zinc. Solid zinc different value, liquid zinc different value, zinc vapor different value. So what is it? M is 65.3 and CPM is liquid zinc is 0.109. 0.109 into dt. Q3 no? 907 minus 419 here. So this is kilocalorie per kg per Kelvin 0.109, yes, and it is per Kelvin because plus 273 plus 273 gets cancelled, and here it is a kg, Kelvin. You will get Q3 is equal to 3473 0.4376. Maybe small difference, we don't know. You check if there is difference in the value. 3473. Okay. So this is a Q3 value. Now we calculated up to here. Next Q4, Q5 are remaining. Next Q4 is heat to be supplied. Heat to be supplied. Q4, this value, Q4, okay? Heat to be supplied. Here we have liquid zinc and here we have zinc vapor. To convert zinc from liquid form to vapor form. Heat to be supplied to convert zinc liquid at what temperature it is? 907. At 907 degrees centigrade to zinc vapor again at 907 only you are getting. First you need to get at the same temperature, that is latent heat of vaporization. Whatever the heat we are supplying, that will be used up only to convert from liquid form to vapor form. That is why the thermometer will not show any rise in the temperature. After the completely the liquid is converted to vapor, then again the temperature will start rising. Okay, then again sensible heat. So this is what now NCPM dt, that we will see depending on this CPM is what now heat capacity of mean heat capacity of zinc here, because this is a latent heat calculation, lambda V. Okay, this is a latent heat calculation, lambda V. So lambda V is given in which unit? Let us see. Lambda V, latent heat of vaporization, is given as heat of vaporization 26,900 kilocalorie per kg mole. It is given. It is given as a kilocalorie per kg mole. So shall we take N here? So here N is latent heat calculation. Okay, N is what? 1 kilomole into lambda V value is 26,900. 26,900. Okay, this is kilocalorie per kilomole and this is a kilomole. Kilomole gets cancelled. So Q4 is equal to 26,900 kilocalories. Okay, this is a Q4. Next, Q5. What is Q5? From here to here. Q5 is heat to be supplied. Heat to be supplied to heat zinc vapor at what temperature? Initially we got at 907 degrees centigrade. To zinc vapor at 1200. This is the last calculation. Okay, at 1200 degrees centigrade. It is heated from 907 to 1200 degrees centigrade. So what is the sensible heat calculation? So CPM dt, what is NRM depends upon CPM unit. What is given we will see. Heat capacity per kilomole it is given. Okay, so we will take N. It is given as mean heat capacity of zinc vapor. Data is given. Per kilomole it is given. Okay, so this is 1 1 kilomole into CPM value is zinc vapor 4.987. 4.987 kilocalories. It is given like this, kilomole degree centigrade. No problem here. In the denominator, 1 degree centigrade equal to 1 degree Kelvin. And because it is given centigrade, we are writing like that. And then 1200 minus 907. Okay. So this is degree centigrade. Kilomole. So this value is 1456. 1456.21 kilocalories. Okay. So now we have calculated Q5. So all the Qs we have calculated. Now the total heat to be supplied, add up, you will get the total heat to be supplied, this Q. Therefore, total heat to be supplied from what relative to solid zinc at 10 degrees centigrade to solid zinc at 10 degrees centigrade to zinc vapor at 1200 degrees centigrade. Okay, zinc vapor at to convert total heat to be supplied to convert solid zinc at 10 degrees initially to zinc vapor, that is finally. What is this? This is nothing but what actually the question is represented like this. Enthalpy of nothing but enthalpy of zinc vapor. This only is that. Enthalpy of zinc vapor at 1200 degrees centigrade. That only is enthalpy. This is equal to Q. Okay. So which is Q is equal to what now? Q1 plus Q2 plus Q3 plus Q5. Okay. Therefore, Q is equal to, now substitute all the values. 2804.3085 plus 1660 plus 3473 plus 0.4376 plus 1, 2, 3, 4, 5 are there. 26,900 plus 1456.21. This is equal to 36, nearly equal to, okay, 36. You check out the calculation once. 36, 293.9561 kilocalories, isn't it? This is all in kilocalories. That is, Q is nearly equal to here 36, 294.9, round it up to kilocalories. That's 600, nearly 300 we can say, 94 or nearly, that's 6,300, nearly. Okay, 94 only. Rough value. This is the actual, because it all depends on your calculation, some difference. Okay, this much 36,300 kilocalories of heat energy is to be supplied to convert solid zinc at 10 degrees to zinc vapor at 1200 degrees centigrade. Thank you.